Hello students, this is Suji George, your chemistry tutor. So, we were discussing about electrolysis in the previous two classes. So, what is electrolysis? Yes, it means electro means something which is related to electricity, and means lysis means splitting up or breaking up. Okay, and we have learned about electrolytic cells. It is the place where electrolysis happen, right? And then we studied about electrolytes, which is the liquid or the chemical substance basically which conducts electricity. When does it conduct electricity? In its aqueous form or molten or fused form. Okay, then another term that we learned was about electrodes, right? So what are electrodes? Electrodes are basically rods. There are two rods which helps in the passage of current. It deals with current enters inside the electrolyte and it leaves the electrolyte through these rods. And in an electrolytic cell, there is a beaker or a big vessel over here, and two rods are immersed inside it. Yes, you have studied. And one rod is connected, both the rods are connected to the batteries available, and these rods are immersed inside the electrolyte. Okay, so electrolytes are substances which conduct electricity in the form when it is in the form of aqueous form or in the molten form, because in the aqueous form there is ions present, and positive ions are called cation. I used to put a plus sign over here, and negative electron is called the anion. And the electrodes has also got the name cathode and anode, because cations moves towards the cathode and anode moves towards the anode, and thus it got the name cathode and anode. Now our question is cathode and anode what is the sign on it? Is it a negative cathode? Is a negative electrode or a positive electrode? For that, you will usually have some kind of problem in remembering that, but no, do not panic. Okay, you should not what? You should not panic. PANIC. From this word itself, we can find out which electrode is which one. So, positive is anode. Pa, positive, is anode, and NiC, negative, is the cathode. So, we can say, as you have studied about all these things, we can say that the positive terminal of the battery or the electrochemical cell is connected to the anode. And here there will be cathode, and negative sign will be cathode, and the positive ions will be moving to the cathode and the negative anion will be moving to the cathode. And then again you learned about the reactions that is happening inside the electrolytic cell. Okay, so at one terminal or one electrode, oxidation will happen and one electrode reduction will happen. We will take panic again. We will have doubts which where it will happen. Okay, so Pa at positive anode, oxidation happens. You know why? Anions are negative ions. What do they have? They have the tendency to lose electrons because they have got an extra electron over there. They have the tendency to lose electrons, and thus losing of electrons is called, what is it called? Oxidation. So at the anode, at the positive anode, oxidation of the anion takes place to give the corresponding element. And what happens here? You have heard of MCR Munda. Just remember about NCR. Okay, or NCR. NCR. Okay, NCR means, what does it mean? At the negative cathode, reduction happens. What happens to the cation is the ion which migrates towards the cathode. What happens to the cation, the positive ion? It does not have, it lacks one electron, right? This ion is, it already has lost its electron while combining with the other non-metal. So what happens here? Here it gains and thus reduction happens at the cathode. All these things we have learnt. And again, sometimes there are electrodes which are inert. That is, inert electrons and active electrons. The inert electrons does not participate in the chemical reaction. They only stand there just to pass the electricity into the water or to take out electricity. Okay, just a medium. It is a medium to pass or electricity to enter or electricity to leave. But there are active electrodes which are present. So electrodes are according to its negativity and positivity, positive and negative, where they are connected. It can be called as an anode and the cathode. Again, if it is there are other two types, we can say sometimes these may be inert and sometimes these anode and cathode will be active. So inert examples are carbon, rods, or platinum rods also does not much take part in the reaction, but active electrodes are electrodes like copper, zinc, iron, etc. Okay, when does it get active? When the electrolyte is there on salts. Only in the active case, only this metal with which it is made undergoes oxidation and reduction. Okay, only Cu2. If it is CuSO4 and the electrode is Cu, only Cu atom or ion will be undergoing what? Reduction and oxidation at the electrode. And chemical reactions always happens at the reduction. And again, we have learned about, we have seen two words called dissociation and ionization. Can put Z or S over there. Sorry. So, other two words that we learned in terminology is dissociation and association. We will see what that is all about. Okay. Now, firstly, we'll see what dissociation is. Okay. So, I have already said that or we have learned that acids, some bases and salts are responsible for, or they are good conductors of electricity. Why are they good conductors of electricity? Because they form ions in aqueous solution. Okay. And there are, among salts, there are ionic compounds. Okay. Compounds which is formed by complete transfer of electrons to the, yes, compounds that is formed uh, by the complete transfer of electrons from a metal to a non-metal. So most of the compounds, there will be a bond between a metal and the non-metal, right? So here the metal gives its electrons, complete transfer of electrons, and inside the crystal itself, inside, if you are taking NaCl, this compound, you can see a structure of Na positive ions and Cl minus ions in which will be bonded like this inside that crystal of the compound. Okay, and the bond between this is already present in an ionic compound. The constituent ions or atoms are already present in its ionic form, right? And but in its solid state, these ions will be bonded. This bond will be very strong. It is strongly bonded. But when you add water to it, if you take aqueous solution, or if we try to melt it by applying heat, the bond between this, the bond between these two ions will become weak, and we will be explaining it how. So one case is that, first case is that aqueous solution. What happens to a ionic compound or an electrovalent compound when water is present there? Okay, so Na positive is there, Cl minus is also there over there. So let's see what happens. They are held together by electrostatic force. But when water is added to it, since water being a polar bond, water is what? Water H2O, right? There is an oxygen atom, and two hydrogen atom are bonded with each other. Oxygen is an electronegative atom, and hydrogen is an electropositive atom. Okay, negative means, electronegative property means this oxygen has the tendency, in this it is a covalent bond, water is a covalent bond, still this oxygen has the tendency to pull the electrons which are being shared. Two electrons are shared in between. This oxygen pulls these electrons towards itself, and it will acquire a partial negative charge, right? And in that case, these hydrogen will acquire a partial negative charge. This is called. So, some covalent bonds are polar in nature, or they undergo polarization, polar in nature, and oxygen will have a negative shade, and I can say like that also, and hydrogen will have a positive shade. What happens when these two come together? When these two come together in a solution, oxygen will be attracting, oxygen will be pulling sodium also towards itself because of its negativity. Sodium will be pulling sodium, positive sodium cation, and the hydrogen will be pulling the negative Cl minus. And when that happens, what happens? When this happens, the bond between Na and Cl will weaken, and that is, and produce ions will be formed. Okay, and this type of splitting of ions is known as dissociation. And one method is that you can, if you add water into it, it will dissociate, or it will be pulled apart and the bonds will be weakened and it will form as ions. And second thing is that we will see in the page from the textbook. I'll just zoom it for you. Okay. Yes. What happens in the molten state? In the molten state, because of the high temperature, we need high temperature to melt the object, right? Because of the high temperature, yes, the bond between the solid bond, which was very strong, that bond between the particles weakens and this lets the ion free. Okay, so what happens? There will be a friction over there and it will be pulling, or it will cause weakening of the bond in case of when it is melted, and thus this helps in the dissociation of what kind of ions? Dissociation of ions in the aqueous state and in the molten state, and hence ion is present, electricity can pass through it and it becomes a good conductor of electricity in the aqueous state and in the molten state. This will not happen in solid state because normally these ionic bonds, the bond between the two atoms in an ionic bond is very strong. Okay, so in solid states, electrovalent or ionic bond or normal salts or even acids or base in solid or dry state will not conduct electricity. Okay, that was about dissociation. And let's see what ionization is. Okay, so what is ionization? For ionization, we are speaking about the covalent molecules or covalent compounds. Earlier we were talking about ionic compounds, but now we are talking about covalent compounds, where compounds are formed by sharing of electrons. You can see sharing of electrons in a covalent bond, right? Okay. So what happens here? There are certain covalent molecules which are not made, it is not made of a ion, but when dissolved in water, these solution conduct electricity. So when it dissolves in water, it ions are formed and it conducts electricity. The process by which the covalent compounds are converted into ions in water solution is called ionization. So what is the difference between ionization and dissociation? Dissociation happens mostly in, it happens in ionic compounds, and ionization happens in covalent bonds when it is dissolved in water. For example, HCl. So let's see what happens over here. HCl in its gaseous state or in pure liquid state, HCl is it is unionized. No ions, already there is no ions. It is completely unionized and it does not conduct electric current. But however, there is a polar nature. What is a polar nature? We just show the polar nature of water, right? So here hydrogen is an electropositive, highly electropositive, and fluorine is an electronegative. What happens? There is a shared electrons between the bonds, and chlorine will be attracting this towards that side. Chlorine has that tendency. And what happens there? Polarity develops, a partial polar charges over there. Okay, so however they are polar covalent in nature, and thus what happens? It shows the The charge distribution in the molecule will be such that hydrogen atom is slightly positive charged and chlorine atom is slightly negative charged. And when water is added, water is also again what? Polar. The water also has a positive and negative side shade. So the H positive ion on the water, or sorry, the hydrogen, which is partially positive from the HCl, will be attracted to the which part? Oxygen, hydrogen part, and yes, and you will be getting a separate molecule of chlorine. What happens there? It is shown over here. So when hydrogen chloride is added to water, it is also a polar solvent. A slightly negative charged oxygen atom of the water exerts an electrostatic. So HCl, in HCl, hydrogen has got a slightly positive charge, and water here has a slightly negative charge on the oxygen, right? And this will pull hydrogen will be attracted. And what will happen here that this hydrogen from HCl gets added and we get a hydronium ion, and this will split into hydronium ion and Cl minus ion. Okay. So it is over here. So when hydrogen chloride is added to water, which is already, it has got a polar nature, a slightly negative charged oxygen atom of the water exerts an electrostatic pull on the slightly positively charged hydrogen atoms present in the molecule of HCl. And two ions are formed. Hydronium ion, which is the cation, and the chloride ion, which is the anion. So, what you can infer from that, during electrolysis, if water is present, how many numbers of ions and cation and anion will be present inside an electrolyte? So, if you take the case of NaCl plus water, there will be Na positive ions, Cl minus ion, H plus ion, O and OH minus ions. These many, this is 4 or more, sometimes it will be present in the electrolytes. Okay, then how will you decide which one will get oxidized or reduced? So there are two cations which will be migrating to the cathode, and there will be two anions which will be migrating to the anode. Among this, which will be liberated or discharged at the anode will be decided by its reactivity, or whichever reactivity or whichever has that tendency to lose electrons more or gain electrons more will be discharged at the electrodes. And for that, we need to learn the electrochemical series. Okay, so before going into learning about electrochemical series, we will just compare the ionization and dissociation. All these comparisons, what is the difference between an electrolyte and a non-electrolyte, anode and a cathode, anion and a cation, active and inert electrodes, then about strong electrolyte and weak electrolyte, and also what is the difference between an electrochemical cell and an electrolytic cell. All these differences are important in the exam point of view. Okay, you need to know about it. You need to know everything about this. You might feel that it is all theory, you don't need it. No, this is a very important chapter. Different kinds of questions will be asked from it, and these are the most important ones. Okay. So ionization and dissociation, we already have studied that ionization happens in covalent bonds, polar covalent bonds, and dissociation only happens in ionic bonds. Then what are they? Formation of positively or negatively charged ions from the molecules which are not initially in the ionic state. Or in their original state there isn't already present, is not already present there. It will only be present when water is added to it. Dissociation, the case of dissociation, already they are present in their ionic form inside the molecule, inside the whole crystal. And the second is polar covalent bonds show ionization. For example, of covalent bonds are HCl, NH, H2CO3 is what acid? Carbonic acid, and NH4OH is a base which is ammonium hydroxide. They will split into two in the presence of what? We have already given that. Yes, see, water is there. Water has a polar nature. These covalent bonds also have polar nature. So what happens? The oxygen in the water will be attracting or pulling out. It just pulls out the hydrogen from our polar covalent bond. So electron bond, already there is dissociation. Potassium chloride is given there. What will be the formula of lead bromide? Can you tell me what is the formula for lead bromide? Lead, what is the symbol? It is Pb. And how will you write for somebody to write down the chemical formula? What are the things we need to know? We need to know the symbol, and also we need to know the combining capacity or valency. And valency for lead is 2 plus. And valency for Br, what is the symbol? I already told you, bromide is Br and it is negative. So crossing over, we will get the answer PbBr2. Okay. So PbBr2, when it dissociates, we will get Pb2 plus 2Br minus. Okay. Right? Yes. Pb2 plus and 2Br minus. So that is how lead bromide dissociates. So you in this chapter later you have to study about the electrolysis of lead bromide. So in that point of view, it is very important to know about the chemical formula and the valency, how it will get ionized and which one will go at which position and all. Okay. So what is an electrochemical series? Okay, we all know that there are metals and non-metals. And among metals, some are very reactive. We have learned in that chapter. Yes, you have already learned. You have already learned about displacement reaction and about reactivity series and all. Yes, of course. So some metals are highly reactive. For example, potassium, sodium, calcium, magnesium are all highly reactive metals. You have also studied the same thing in metallurgy and purification of. You need to know this reactivity series. Okay, these are all highly reactive, and that highly reactive are placed at the top of the reactivity series. Why is this highly reactive? It readily forms. If it is potassium, it will readily form. It will lose electrons very easily. Na will lose electrons even more easily. Calcium will lose then, and this next. Okay. So losing of electrons, or the readiness with which lose electrons, or readiness with which they accept electrons, all are calculated and found out, and then scientists has come to a conclusion about the reactivity series, and they have found out that what? So metal elements lose electrons from their outermost shell to form a positive metallic ion, that you know. So forming potassium gives out one electron to form K positive. Calcium loses 2 electrons, aluminum loses 3 electrons. However, the tendency to lose these valence electrons varies. They all lose electrons, but that tendency varies. Consequently, the metallic elements can be arranged in a the metallic elements can be arranged in a decreasing order of their tendency to lose valence electrons. Decreasing order. So, reactivity series in which it is arranged in a decreasing order to lose. And all these things you have studied. So, if you look at the electrochemical series which is given in the textbook, what can you infer from this? So metals like potassium. In some cases, sodium is written up. Okay, calcium, sodium, magnesium, aluminum. These are all highly reactive. And as it goes down the series, the reactivity is decreased. And also based on the ease with which atoms of metal lose electron to form positively charged ions, the metals are arranged in a series known as electrochemical series. Okay, so it is arranged like this. As we go down, it has the tendency to lose electrons faster. That means what? It means that it losing of electrons is its upper one gets oxidized very easily downwards. Yes. So increasing ease of discharge at the cathode is seen over there. So what happens? Okay. So after that zinc will be giving, and then iron, nickel, tin, lead, hydrogen. So mostly we used to say that above hydrogen, the reactivity is more. The tendency to lose electrons for these atoms is more. Okay. So because of that, at the cathode, what happens actually? Gaining of electrons happens at the cathode. So when this reaches the cathode, when H positive and Na moves to the cathode for reduction, what happens here that instead of Na positive getting reduced, H plus will be easily getting reduced at the cathode. Okay? Because what? Because Na positive has the tendency to lose electrons more than H positive. So the ions which is lying up, if upper to the hydrogen, will be having less tendency to get reduced, and which is lying under hydrogen, it will have more tendency to get reduced. Okay, at the cathode. So we will discuss about this. You also have learned about the mnemonics, that easily you have to know the series, how it is arranged. Okay, that is very important. You have to learn how it is arranged. We have so many other methods. Whatever you have learned, I have learned in this method saying that please stop calling me a zebra. I like her. Call me smart guy. Okay, this is a mnemonic that I used. So in different texts, sometimes sodium comes upper than in a higher position than calcium, zinc and to something nickel is given over there. We will not be learning about zinc and nickel, so that is will be omitted. So please means potassium, sodium, then calcium, Me magnesium, and this is aluminium, zinc, iron, lead, hydrogen, copper, mercury, silver, and silver is Ag, and gold. Gold is Au. This is mercury, and then platinum comes. This is the series, and if whatever you have learned, whatever it is, you have to learn it. Then only we will able to do reactions or solve the reactions like displacement, double displacement, and all. Okay, and also it is very important to know it in the electrochemical series as well. Okay, so about electrochemical series of metal, a metal with a higher position in the series, metal with a higher position in the series displaces the one with the lower position in a chemical reaction. Okay, the metals below hydrogen cannot displace hydrogen from acids while those above it can. For example, we have studied about when zinc reacts with HCl. What will happen? Zinc will displace, zinc will kick out our hydrogen from its solution to form zinc chloride. But what if copper is reacting with iron? This reaction will not take place because copper is lesser. Copper has lesser reactivity than hydrogen. So copper will not be able to displace. See, copper is down. Will not be able to displace hydrogen. This is they are telling about displacement reaction. Okay. Then this is the point that we need to look. Elements in the lower series gets discharged more easily at the cathode because their cations can easily gain electrons. So what is the tendency of the topmost ones? They easily give out electrons. They easily lose electrons. So the tendency of gaining electrons will be down ones. Okay, so the lower ones in the series will get discharged more easily at the cathode during electrolysis because their cations easily gain electrons. So cations are the ones we have learned, na? P, A, O at the anode. There will be oxidation at the cathodes. There will be reduction. So cations undergo. We have learned about cations, electrochemical series, how cation is arranged, and the cathode reduction will happen. So what is it? The elements in the lower series gets discharged more easily at the cathode during electrolysis. Okay, because their cations can easily gain electrons. Then metal atoms which form their atoms more easily will accept electrons back from the atom with great difficulty. It is said about the atoms which lie on the top. Okay. Hydrogen has some properties of a metal. Formation of a positive ion, thus its position among the metal confirms the identity with the metal. Therefore, it has been placed in series. This is telling about hydrogen. So, hydrogen can be considered as a metal and a non-metal. So, because of its appearance, it is a gas. So, we can't, usually it is not considered, sometimes it is not considered as a metal have a characteristic of it will be hard and all those things. But hydrogen, since it is there in this series, we can say that hydrogen can be considered as a metal. So the only point that we need to know from this is the third point. What is it? The elements lower in the series. If we have two or more cations in an electrolyte, then elements that lies lower in the series will get discharged at the cathode by gaining electrons because they are the cations which gains electrons easily. Okay, right. Okay then. So there is an electrochemical series of anions as well. And the first one there is SO4 2 minus. Only few are written over there. Then comes NO3 minus. If you can find out a mnemonic for this, then it is fine. Otherwise, there are only 6. You need to remember the order. Okay. And then comes chlorine, then comes bromine, and then comes iodine. Chlorine, bromine, iodine, this is the series which is there in the periodic table as well. So, SO4 2 minus, NO3 minus, Cl minus, Br minus, and the last is HOH minus. Okay. So, in this case, down, increasing oxidation, increasing order of discharge. It is written over there. Can you see? Yes. Increasing case of discharge, increasing order of oxidation. And so what happens here? Here also there will be the one which is below in the series will be oxidized first in case of when it comes for discharge. Okay. There are so many factors. So another topic for us is about preferential or selective discharge of ions at the electrodes. So depending upon the electrochemical series and of cations and anions, the discharge of electrons at the cathode will be decided. That is the one. And then again, it depends upon the maximum number. Discharge or selective discharge depends upon the maximum number of electron and also the nature of electrons. So selective discharge happens. When will selective discharge happen? When two or more, we have said about this, when two or more ions of the same charge are present in the solution of an electrolyte under identical conditions and are competing for discharge as the same electron, one of them gets preference, and that is called selective discharge. And there are 3 main factors with which it is dependent. Okay, so I think we can end the class now. So today we have studied about what dissociation and ionization, how chlorine ion is sodium chloride ion is dissociated in the presence of water or in molten state, and what will happen, or in ionization and dissociation, what happens to the salts and salts in covalent bond, salts with ionic bond, what will happen to it. And then we have learned about the electrochemical series with which in which the ions are arranged in their decreasing order of reactivity, or increasing or decreasing order of their reduction and oxidation. Okay, so let us wind up the class for today. We'll be seeing you with more topics. Till then, it is bye from me. Okay, bye bye. Have a great time.